Okay, so in this worksheet, putting it all together, directions. Each problem below is labeled to indicate how it should be completed. The labels have the following meanings. Me, I, your teacher, will demonstrate how to solve the problem while all students pay attention and ask questions, which will be difficult because this is a video. Together, we will solve the problem together on the board, and you will solve the problem on your own. Okay, so 1A, together. We're going to solve 7m minus 5 greater than or equal to negative 68. Okay, so we draw our river. Okay, so negative 5 and negative 68 are our like terms, right? But they're on opposite sides of the river. We need to do opposite operations to get them together. So we're going to do plus 5, plus 5. So I have 7m, and then negative 65 plus 5 is negative 63. And we learned that adding with an inequality doesn't change our inequality, so it stays. Okay, next we're going to divide by 7, right? Opposite sides, opposite operations. So I'm going to get m and negative 9. And we learned that dividing by a positive doesn't change my inequality, so it's going to stay greater than or equal to. So to graph it, I'm going to put negative 9 on your number line. It's a solid dot, and greater than goes this way. Okay, so you are going to do this one. So you could pause the video or go back and do it later. Okay, number 2. Draw our river. Okay. Negative 3g plus 5 greater than 20. 5 and 20, opposite sides of the river, so you're going to minus 5, opposite operation. So negative 3g, I get 15, 20 minus 5. Subtracting 5 does not change your inequality, so it stays greater than. Negative 3 and 15 are on opposite sides of the river, so I have to do opposite operations. So divide by negative 3. So I have g and negative 5. Do a less than. So my answer is g is less than negative 5. So I'm going to put negative 5 on my number line. It's an open circle, and less than is to the left. Okay, and you are going to do this one. So you can pause the video now, or you can go back and do it later. Okay, so Mount Snow has a special pass for $215 that discounts daily lift tickets for only $20 each. Ski Sundown offers a season pass that allows unlimited lift tickets for only one price of $485. How many lift tickets would you need to use for Ski Sundown to be the better deal? Answer in a full sentence that makes sense. Okay, so first we're going to define our variables, which means we're going to say that t is equal to the number of lift tickets. Okay? So for Mount Snow, we have $215 plus $20 for each lift ticket. Okay, and for Ski Sundown, we just have $485. Okay. Oopsies. All right, well, let's do this. There we go. All right, so we want to know when when Ski Sundown is going to be less than Mount Snow. So we're going to write an inequality. So we want 215 plus 20t to be greater than $485 because we want this one to be the better deal. Okay, so let's solve this. Okay, we've got our river going down the center. Okay, 215 and 485 are on opposite sides of the river. So we're going to minus 215 to get it over there. So 485 minus 215 is 270. So I have 220t and 270. And subtracting does not change my inequality, so it stays the same. Now I've got 20t and 270, so I have to do my opposite operation, opposite sides. So 270 divided by 20 is 13.5. And dividing by a positive doesn't change my inequality either. So I get t has to be more than 13.5. Okay. Then it says answer in a full sentence that makes sense. Okay, that makes sense. Can you buy 13.5 lift tickets? No. So you will need to buy at least 14 lift tickets for Ski Sundown to be the better deal. Bam. Okay. Right, and this was just the rest of my word problem. I had to move it to the other page. Okay, then to graph it, we're going to graph 13.5 bigger. need to have, next one is one that you're going to do on your own. Okay, 4A. This one has distributive property in it. Okay, so we need to distribute. So we get 3Q plus 3 is less than 3Q plus 7. I'm going to draw my little river. Okay, since we have variables on both sides, I'm going to move my variable first. See, I have 3Q here and a 3Q here, so I have to move my variable first. They're on opposite sides, so I have to do opposite operation, right? So I'm going to minus 3Q, minus 3Q. Oh, look what happens. The Q's wind up canceling out. So I'm left with 3 and 7. Subtracting doesn't change my inequality. So I have 3 is less than 7. Is that a true statement? 3 less than 7? You need to think about that. The answer is yes. This is a true statement. If your answer is a true statement when your variables cancel out, then your answer is all real numbers, or infinitely many solutions. You could also write this symbol. Okay, that means all real numbers. If this came out to a false statement, then your answer would be no solution. Okay, so if the variables cancel out and you get a false statement, then your answer is no solution. Okay, so this one you are going to do on your own. Okay, so you could either pause the video or go back and do it later. To graph all real numbers, we do this. It's every number on the number line. Okay, 5A. We have two distributive properties. So I get negative 3 times negative 4 is positive 12p. Negative 3 times 5 is negative 15, greater than or equal to. Positive 5 times 6 is 30p. 5 times 15 is 75. Oops, why am I not writing? There we go. Okay, then we're going to do our river. Okay, I'm going to move my p's first. So I'm going to do minus 30p. I like to move my variables to the right side, left side personally. But okay, so 12 minus 30 is negative 18p. Bring this down, minus 15, 75. And then subtracting doesn't change your inequality, so you still have a greater than or equal to. Okay. 15 and 75 are on opposite sides of the river, so you have to do plus 15 opposite to move it. So bring down, so I have negative 18p, 75 plus 15 is 90. Adding doesn't change your inequality. And last, I'm going to divide by negative 18. I get p, negative 5. Dividing by a negative, however, is going to change this symbol, so it's going to become a less than or equal to. So I'm going to redraw that number line because it's kind of on my sheet anyway. So I'm going to have a negative 5. It's a solid circle, and less than is in this direction. Okay, and you guys are going to do 5b. So again, you can pause, or you can go back and do it later. Okay, number 6a. Again, we are going to distribute. 4 times r is 4r. 4 times 1/2 is 2. Then minus 3. Don't forget about that minus 3 out there. Is less than or equal to. 5 times r is 5r. 5 times 1 is minus 5. And then plus 4. Forget about that plus 4 out there. Okay, then we're going to combine like terms first. I have like terms right here, and I have like terms right there that are on the same side of the river. So I have 4r minus 5 and I have 5r minus 1. If you're wondering how, I have plus a negative, and plus a negative. So negative 2 plus negative 3 is negative 5, and negative 5 plus 4 is negative 1. Now I'm going to combine my variable terms. So minus 5r, minus 5r. I get negative 1r minus 5, less than or equal to negative 1. And I'm going to do plus 5, negative 1r, and 4. Divide by negative 1, r, negative 4, and I divided by a negative, so I have to switch it to a greater than. To graph it, negative 4, solid circle, Greater than goes to the right. Okay, you are doing 6B. So you can pause, or you can go back to it later. Okay, so for this worksheet, passing linear inequalities, the first student who receives this problem set should only do the first step in solving the inequality. Then pass the problem to someone else in your group to do the second step. After they completed the second step, they will pass the problem to the other student in your group. After the third student completes the final step, they will pass the paper back to the first student, and the first student will check the problem to see if it's correct. Repeat the process for the second problem. Okay, so you guys are going to be working in groups of 3 to do this. Okay? So work in groups of 3. Okay? You will each do one step. Then pass the paper. Okay? That's how this works. Right, so get in groups of 3. There should be 4 groups of 3. There are 12 of you. And that's how I want you guys to do this. In each problem, I want a different person starting the problem off. So in problem 1, one person starts with step 1. In problem 2, the second person does step 1. And in problem 3, the third person starts with step 1. Got it? Good. All right. See you in the next video.